how we can, in this tutorial we'll show, once we have a planned path, how we can write a controller so that we can follow the trajectory of the computed path. In order to do that, we'll be launching again the same launch file to have the robot in Gazebo simulator and visualize in RViz. And the secondly, we'll be running another node called follow traj. And if we run the follow traj node, then we see that the robot starts moving following the computed trajectory that we have computed in the previous tutorial. And the controller that we have implemented here is basically nothing but a pure pursuit controller. It is very simple but very effective. I'll show you the script written in Python, how this pure pursuit controller is working behind the scene, but here is how the followed trajectory looks like. So it looks like the robot followed the trajectory well and it finally reached the desired position or the pose, and here is the plot of the planned and actual trajectory that the robot has followed and the desired trajectory of the robot. And it looks like initially there was a deviation, especially when there was a steep curve. After that, in the other portion of the curve, the robot followed the trajectory pretty well. Now, one important thing about this pure pursuit controller is that the robot needs to have spawned wherever the initial pose of the path has been requested. Otherwise, there will be a very high input error that the controller will incur and the robot may not be able to follow the trajectory at all. And other thing is that the way this code has been written, it assumes that all the path data is written somewhere. In my case, it's written as a pickle file that basically includes the sequence of x, y and theta coordinate and also the velocity, linear and angular velocity profiles in a pickle file. So it uploads that file and then tries to understand what is the path that it has to follow, and it generates the corresponding control input to follow the trajectory. And now I'll show you the Python script, and the script is located inside the Pioneer planning package. And if you go inside the node folder, you will find out the follow traj.py script, and here we see that it first creates a TF transform listener object so that it can have a track of the odometry values, and then it also creates an object for publishing the velocity, and then in here it creates an object for the geometry messages twist class. And here this is very important, that at what rate the robot publishes the velocity. So this rate has to be very close to the integration time that has been used while computing the path plan, as I have shown it in the previous tutorial. So in the previous tutorial I had the integration time as 0.1, which essentially means that I should publish the input velocity at a rate of 10 Hertz. But I have seen that if I set the velocity, publishing velocity at 10 Hertz, then the robot may not follow the trajectory well. So I found that 12 is the optimal one. So this is kind of engineering stuff that one can do. Another thing is this part. And this part assumes that all the trajectory or the computed path is written in a pickle file in this path, and then it basically loads that file and extracts the path data, what is the velocity profile, all this. So the path data includes the x, y and theta coordinate. Vd is the linear velocity at each time step, and Wd is the desired angular velocity at each time step. And then depending on how many data points you have in the path plan, it basically loops over all those data points, and at first it tries to get the odometry data, that's initially to identify where exactly the robot is, so what is its translation and rotation about the odom coordinate, odom frame, and then it finds the error about what is supposed to be to follow that track and trajectory, and depending on how much error it incurs, it basically computes the input linear and angular velocities, and then it basically trims the input velocities within the allowable limit, both for the angular linear and angular velocity, and this keeps on looping through all the data points. And I think this is all about the followtraj.py script, and hopefully this will be useful for writing a simple trajectory following controller. Thank you.